Amidst all of these AI updates and news, do you also feel this urge to dive deep into the model architecture to really understand what it takes to train a model like Llama 3 or DALI? Well, I have been facing this urge constantly for quite some time now. And finally, I gave in and decided to create my own research program to dig deep into the world of AI research and engineering. Now, I know that I'm not cut out for a PhD. My brain is wired to build, to implement, to bring ideas to life as soon as they click. So I go and start thinking about how to sell it, how to derive value out of it. But I also know that to truly grasp AI, you need more than just surface level knowledge. So that's when it clicked me that if Tim Ferriss could design his own personal MBA, I can also design my own AI research program, which is tailored to my style of learning. So here's what I did. The first step that I took was to understand what top research engineers in the world actually do. What are the skills and what are the type of tasks that they work on? So I dove into job descriptions from top AI companies like OpenAI, Anthropic, Meta AI to understand the role of a research engineer. Here, let me break it down for you. Research engineers are basically kind of like Swiss army knives of the AI world. They are responsible for building large-scale systems. So these research engineers will build massive ML systems from the ground up. They are experts in distributed computing and system architecture. A typical project can look like scaling a training job to thousands of GPUs, which would be a real test of patience and debugging skills. These folks are constantly optimizing these systems. They might spend weeks fine-tuning a new attention mechanism for peak performance. And this requires deep understanding of ML algorithms and a talent for performance optimization. Data preparation is a crucial part of the job. You can imagine transforming Wikipedia into a format ML models can easily consume. It's like being a data chef. You need to know your ingredients, which could be your data structures, and how to prepare them, how to build these large-scale ETL processes. Experimentation and research. Research engineers design and run scientific experiments. They compare different model architectures or training techniques. These engineers are at the forefront of developing safe and trustworthy AI systems. Furthermore, research engineers often engage in pair programming. They work with distributed teams, so they need to be able to communicate complex ideas clearly, often through publications and open source contributions. After understanding the skills and responsibilities of an AI researcher or a research engineer, I finally defined the main pillars of this AI research program, which further entail many topics, subtopics, the kind of projects, the kind of research papers that you have to read, everything. I provided the link of this GitHub repository in the description below, so you can go through it in detail. But here, I will highlight pillars and the definition, what it entails. First of all, we'll start off with foundational knowledge. The core mathematical and theoretical concepts that underpin AI and machine learning. Linear algebra, calculus, information theory. Pillar number 2, programming and tools. All of these research engineers are great programmers. You have to be really good with Python, PyTorch, Git, Linux, all of these tools for AI development as well as deployment. Deep learning fundamentals. These are basically key concepts and architectures in deep learning and neural networks. So you need to be good with understanding these architectures, reading papers, how they developed over time. Attention mechanism, transformers are at the heart of the new age language models. Pillar 4, reinforcement learning. Principles and applications of reinforcement learning in AI. How methods like RLHF are being used to train models like GPTs. NLP, LLM research. Advanced topics in natural language processing and large language model, how we went from word to vec to training GPTs and then fine-tuning these models, and further on the kind of new age applications that are being built on top of LLMs like RAG, agentic workflows, so on and so forth. Pillar 6, research paper analysis and replication. You should have the skills to critically analyze and reproduce cutting-edge AI research. Pillar 7, high-performance AI systems and applications. Now, these models are trained on petabyte scale data. So you should be equipped with techniques for optimizing and scaling AI systems for real world applications. Large scale ETL and data engineering. So these are basically topics and methods for handling and processing large scale data for AI applications. Ethical AI and responsible development. These are ethical considerations and responsible practices in the AI development space. Pillar number 10, community engagement and networking. You should know how to build connections, how to participate in conferences, how to contribute to open source, and all of this is at the heart of AI research. Lastly, research and publication. Conducting original AI research and sharing your findings through academic publications. These 11 pillars combined together basically build our AI research program. Now, I personally have an inclination towards LLMs and NLP. This seems like it is catered towards that audience, but you can always tweak it to make it more computer vision oriented, or if there is any other tangential field in AI that you are interested in, feel free to tweak this checklist as per your learning style. Now, this will feel overwhelming and humbling at first, but remind yourself that you don't have to go through all of these pillars. You don't have to build expertise in every single topic out there. So here's how you have to consume this entire program and all of these topics that I have enlisted here. Assess your current level of understanding. And then you have to craft a project around it. Define a goal for yourself. Once you have done that, you have to focus on building that project iteratively. You have to go back to the learning resources if you don't know something. Learn how to apply them. Go through documentation, books, courses. Create concrete deliverables out of your projects. Document your process, your learning journey, challenges, ideas, everything. Engage with the community. Now, this whole journey could be very lonely at times. So it's very important that you be part of a community and share your progress. Learn from others as well. Lastly, the best way of learning as per the Feynman technique is to teach, is to write what you've learned. So don't just keep your learnings and your findings to yourself. Write about them. This will also expose gaps in your level of understanding of those topics. So go back to your resources, fill those gaps, and then simplify those complex ideas. Here's how I am kickstarting this program for myself. The project that I want to work on is how to train a miniature large language model. And through this project, I want to learn everything that goes on to training a large language model, from tokenization to embedding to coding an attention mechanism, how to train a model, how to code a model like GPT, and what are the details of those architectures. I want to learn everything. So I'm starting off with LLM research. I've given myself 3 months. Based on my level of understanding, I have decent exposure to these technologies for last 3 to 4 years. Now, as I progress, I will continue to document my entire journey. I'll keep writing blogs. I'll keep recording videos. I'll try to explain these topics as per my understanding. Here, the steps that would be required for me to take. First of all, I'll have to go through and get better at my PyTorch coding skills. So I will need to master PyTorch basics, model architecture and implementation, go through the research papers, re-implement them, data pipeline and training, how to prepare data sets for these training pipelines, how to code the attention mechanism, how to code a model like GPT, fine-tuning a foundation model, and core concepts basically include transformer architecture, embedding models, attention mechanism, all of these. So you should be able to understand and explain these concepts clearly and in a very simplified manner. As I'll move forward, I'll further focus on distributed engineering a lot more. Cloud platforms, how to use those to deploy complete pipelines, how I can help any company fine-tune their models, how to develop their infrastructure, and at the same time create applications on top of it. Now, in order to learn all of these topics and going through these pillars, you'll need a lot of resources. And I have categorized these in blogs, books, courses, papers, projects. And if you head over to my GitHub repository for this program, I have a resources folder here which captures everything. So the kind of blogs, the kind of books that I'm referring to, courses I'm referring to, papers that I will be reading, all of these will be captured in this resources folder. And there will be another folder which will come up here soon, which is going to be weekly notes. So there I will keep adding what I've learned, trying to explain a few complex topics that I've learned. Every single detail is going to be part of that weekly notes folder. Now, one key factor that's going to directly impact the success of this program for you is how to sustain this mindset and motivation over such a long period of time. I can share some of the principles, tactics, hacks that I follow. First thing is, for me, I don't want to overexert myself. This is not the only thing that I'm doing. I have other things as my day job. So I'm going to focus on that primarily. I'm going to give this program 1 to 2 hours every single day, more over the weekends or when I'm on a break. I am following the policy of no 0 days. That means I want to do something every single day. Doesn't mean that I am going to read research papers every day. Doesn't mean I will code every single day. Doesn't mean I will watch the videos of a course every single day. Depends on, how I'm feeling, in what zone I am. And the only thing is that I have to keep making progress every single day. I know it'll compound and it's a long journey that I have committed to. So all I need to make sure is that I'm putting in some work towards this program every single day. Then find more people like yourself. So be part of communities. I have started a Discord server where you'll find more people like yourself. So talk to them, befriend them, focus on giving, focus on providing value. That's the only way you can also get reviews on your learnings, your findings, your projects. And if you want to commit in public, do that. That holds you accountable, just like I am doing it. And lastly, for more motivation, inspiration, you can keep following me. I am going to try to post daily updates. Daily updates are going to be on Instagram and on YouTube Shorts. And sometimes you need to keep an eye on my weekly notes folder within the GitHub repo as well. Now, even though I've spent good number of hours designing this entire program, there are going to be flaws, there are going to be gaps in the program. So don't think that this is complete by any means. You will have to tweak it for yourself. One big gap is mentorship. You need a good mentor or a coach when you are pursuing such a long program for yourself. I'll try to help as many of you as I can. But while I figure this particular bit out, I would recommend that you leverage communities. Okay, ask your peers to give you feedback on whatever you're writing, whatever you're working on, and write cold emails if you could get feedback from somebody who's in the industry. And work in teams. That also helps many a times to do pair programming and get feedback instantaneously. So that's about it. Okay, so I am very, very excited to be embarking on this journey. Let's see how this goes. I would love to have you join me. You can connect with me and be part of the discussions on our Discord server. Follow me on GitHub, YouTube, Instagram for regular updates. All the links are in the description below. And I'll catch you guys in the next one. Until then, keep learning, keep building with AI.